That's just so that I can not ramble on too much and I have like some kind of notes. But I'm not trying to make it very scripted. So, and I'm open to interruptions throughout. So don't think as if this is not a lecture at all. But first, welcome. Thanks for venturing to the west of London. And this is an unusual place for a meetup. Usually everything's happening east side, Shoreditch side, yeah, that other place. But we think the west of London is actually pretty cool. So thanks for coming out on a rainy Wednesday in January, a bit chilly as well. As Dougie said, I'm a Football Radar colleague. So I'm one of the software engineers and a team lead here at Football Radar. And we do lots of cool stuff with Scala and some other languages. And I will tell you none of that. Like, literally tell you nothing about football or about the stuff that we actually do. This will just be an exploration of what I think are some cool things in Scala. And I hope that actually is interesting to you. I suspect most people are, well, I hope you didn't come here for football, because actually I don't really know that much football either. I sort of support Liverpool, but I couldn't tell you where they are on the table. Maybe third, fourth. Are they first? Are they leading? Okay, well then I don't really care then. But yeah, so just a couple things. If you want to be tweeting some stuff, probably tweet at FRDevs, because our guru here, Dougie, will retweet liberally, I'm sure. I think that's my Twitter handle, but I hardly ever tweet, so that could be wrong. So you might be getting to some other Neil, like I think Tony Blair, he has a Neil in his name somewhere, so that's, yeah. But I think that's me, but definitely tweet here if you want. So yeah, let's crack on. So I won't talk to you about football. What will I talk to you about? So a few years ago, I came across this now about 10 years old blog post by some chap called Rafael Ferreira. I've never met him, don't know who he is. Just came across this thing. Rafael, I'll call him Rafael. I like first names. I don't know him, but Rafael seems about right. So that's what the name of the title of the talk is, Another Round for Rafael. So he has this example where he is trying to build, it's a Thai example, an order of Scotch, hence the round in the title, using Scala, but in a Typesafe way, right? So it's pretty old. But I came across it some time ago, and I thought, it's kind of interesting. I don't really have much of a life, so I just, wanted to waste a few hours, doing the same example, trying it for myself, and riffing a bit on it. It turns out actually quite a few people have kind of riffed on the same thing over the years, up to, I think maybe this is the most recent one, someone actually gave a talk at a company, maybe, I think 2016, on more or less the same ideas. So somehow the blog post from 10 years ago has endured and inspired other people to do similar things and riff on it, and even one person has written a library. At the end, I'll have a slide with like a bunch of links to these and a bunch of other things. Hopefully we can share the slides somewhere that people can see. But yeah, I highly recommend that you read the original and maybe read some of the riffs. So this is just another riff, basically. My own riff, because I have nothing else better to do. But hopefully you get something from it. So it's not just me rambling. You get some takeaway from the talk. So primarily what I hope you can kind of get out of it is an orientation, a mindset around viewing the compiler as a way of expressing and validating your thinking, right? And constraining your thinking and how you conceptualize a problem. So it's not just about finding syntax errors in your implementation and bugs in your implementation, but a way for you to express what you think you want in your problem, and then finding some cool features to kind of prove it, basically. So that's the primary takeaway I hope you get. And as a secondary takeaway, it's fine to have some fun and not do anything actually really useful, just to kind of explore some ideas that maybe would be useful at some point. But if, like me, you do Scala in your day job, you probably don't mess around that much with type level things, right? Your job at Scala is probably writing 1 million case classes and some pattern matches and some lots of maps and flat maps and filters and collect. And, this is probably your bread and butter Scala job. It is mine, and there's no shame in that at all. It's really cool. Actually, I do like that side of Scala. But every now and again, it's just worth to spend a little bit of time messing around with this stuff, I think. And I think you learn some things. So So the original talk mentioned Typesafe builder pattern. So I'll just spend a couple minutes or a few slides talking about the builder pattern side of things, which I think almost everyone here, I assume people know what that is, so I won't spend too long. But briefly, I think it originally comes from the Gang of Four book, but this is a Scala meetup. I don't want the cool kids to judge me, so I won't reference Gang of Four. I'll reference Wikipedia and assume that they are the paragons of truth, right? So that's where it came from, not the other book that Scala people apparently don't like. So that's the builder pattern. And basically, to sum it up, it's a way for you to encode how to create complex objects, right? I mean, you can obviously create stuff through a constructor, and that's fine. But perhaps you have something that's quite complex that needs to be built up in stages. So how would you do this in a way that is actually easy to use, that the developer finds kind of intuitive? Through maybe you provide a flow interface that they go from one stage to the next. So that's the general idea. Now the Wikipedia article has like examples in tons of languages, including one that I suspect is a bit unscala, but there it is anyway. You're building a very complex car that only has wheels and color. But in principle, this is the idea that is trying to convey. So I hope everyone is more or less familiar with that, and it's not anything really groundbreaking. One thing that I'll kind of highlight here is, and I only know this as I was preparing the talk, they list some disadvantages of this pattern as the builder needs to be mutable, and you can't be sure that at the end you have all the things that are necessary for the object itself. Now, it will turn out that at the end of this talk, that's not true. So, and that's obviously very language dependent. But I thought that was actually kind of interesting that in this article they have listed these as kind of constraints or disadvantages that for the whole pattern. But basically, if your language allows you to do some other things, you can get around some of them. And by the end, you'll see why. All right. So let's look at the example. Order of Scotch. So Scotch means whiskey, right? Everybody knows Scotch is whiskey, right? I hope that at least you get away from the talk that you're talking about drinks here. And so he sets up a very simple domain model. You have this notion of preparation. He sets it up as some classes and case objects. Could be any num, could be whatever. But very simple domain model where you have preparation, some sort of glasses that your Scotch can have, and your final order of Scotch, which through the types we can see it must have a brand, which we represent as some kind of string. It must have a preparation, so one of neat or on the rocks or with water. You must say if it's single or double, but you can optionally give it a glass. So there are three things it must have and one thing that it doesn't have. Okay, so it's a reasonably simple example. Now, so I set up this whole thing as a builder that builds complex objects, and then they give you a simple object to build. Use your imagination, hopefully. But as the case with most slides, it's really hard to come up with a complex example that you can also fit into a 20, 25-minute talk. So let's just run with this, and it riffs off the original. So just as a first recap of his first approach, which actually already refutes one of the disadvantages of the Wikipedia article, you could just build this up in a really simple, immutable way, okay? And again, this is probably your bread and butter Scala. This is the kind of stuff you would write normally, right? So you start off with a builder that has some elements which are all optional, which represent the elements that will eventually become part of the order of Scotch. You provide a bunch of methods which allow you to kind of move from one state to the other, but instead of mutating the Scotch builder, you're creating a new one each time, right? So you start off with one at the bottom, the builder, very empty with nothing, and then you can in turn call each of the methods, that sets it up, and then when you're done, you call build, and that gives you the order of Scotch that you want. It probably makes more sense if we see how it plays out at a REPL. So imagine you call it like that. Just for some space, I put them all in one line. You probably wouldn't want to do that, but there you go. So imagine you started out with the base builder, and you've called each in turn, and you end up with an order of Scotch, your happy path. And then the sad crying path is you've written everything, but you forgot to call the mode, the preparation one here. So you haven't said if it's neat or on the rocks or whatever. and bang, it blows up because there was a bit when you call the build where this is none. So you haven't called that method, you haven't set the mode, so it blows up. So that's the simplest example. It does the business except when it doesn't do the business. And so the point of the original article was, could we at least make it type safe and not blow up, bang in runtime, right? So this was his first example, which I've just conveniently called type safe style. I hope you can read it at the back. Is it more or less legible? I'll try at bits to kind of pop out some of the text. So hopefully this is the smallest it gets, where there's no pop out. But essentially it's the same shape. So it's, you still have a Scotch builder, the same elements, but now he's introduced three things that we're gonna just go in turn. So the first thing he introduces is these type parameters. Okay, that's the HB, HM, and HD. That's on Scotch builder. Okay, and those each represent, remember there were 3 required things on the other Scotch. So those are the properties that it must have a brand, it must have a mode, and it must say whether it's double or not double. So he's decided, okay, let's lift them up to the type level and add them as parameters on the Scotch builder, which we will fill in. We will actually, it's a parameter, like a function parameter which you call and you fill it in with a value. There's a type parameters, you will fill it in with some actual type at some point. In this case, you will fill it in with one of 2 possible types, true or false. So the first thing was type parameters, the second thing is true or false, which are called phantom types. And so these are phantom types because they don't really have any usefulness at runtime. Right? They don't really provide a useful role. They don't describe or characterize the shape of any objects. There's no methods. There's no nothing on that. Right? So, you call something a true or false. It doesn't help the runtime in any way. But it's potentially useful at compile time. Right? It's something that we can use to constrain. So it doesn't characterize a value at runtime, but it can probably constrain an expression at compile time, which is essentially what we're doing here. So that's the second thing he does. And then the third thing, he's moved the build method, the thing that eventually gets you the order of Scotch, outside of the Scotch builder and into this slightly magical thing at the bottom, which is an implicit conversion, which I'll explain a little bit more. But again, it's probably worth to see it at what it looks like at the REPL. So same thing, happy path, everything's called, and you get an order of Scotch. And then the next one. So I've replaced the sad path with the thinking path. So it's not sad because you haven't blown up anything at runtime, but you have to think. It doesn't work. But now you're kind of like, ooh, why doesn't that work? What the heck does that mean? So in this case, it says there's no build member on Scotch builder. Seems a bit odd. Okay. So maybe I'll just annotate it, and then let's do it. Let's pull the thing out so you can see it at each step. So we start off with the builder, which is false, false, false. So we assign false to those 3 type parameters. So then we call with brand. And if you remember from the definition, every time we call the particular method, we will assign the particular slot, this particular type parameter. So in this case, we've called with brand, so we assign true to the HB parameter. We go to the next one, is double. I haven't shown it here, but it will say true to HD. And so on and so forth until the very end. If you see in the type, just at the point where you call with mode, just after that, you will see something that says true, true, true. Now, so what happens here is now we have a value that has all the 3 type parameters set to true. We will call build, but remember, we have moved build from the Scotch builder. So how the heck does that work? Well, so what the compiler does is, it doesn't just give up. It says, well, can I extend this value I have with this method that you've just written, which apparently comes from nowhere? And it turns out that it will look for any implicit conversion, anything that allows it to go from the value it has to some other value that then will have the method that you're trying to write. So in this case, it will try to go to, let's go back one, to this type that has a build method. Now, his original example, this is something called a structural type. So it doesn't have a name, it just has the shape of what you have. Perfectly legitimate in Scala, but I'll show a replacement where actually people don't really use structural types so much anymore. But the idea is that you extend the existing type with some other type through an implicit conversion. It used to be known as the pimp my library pattern. Apologies if a lot of this is old hat for like lots of you, but maybe it's not old hat for others of you. So for the ones who it's completely old hat, watch what I'm saying, and if I've said anything sacrilegious, like point it out, and then also help to ask some questions at the end. And for the others, thanks for coming and following along, right? So yeah. Okay, so I just wanted to show this bit where highlight the thing with the implicit conversion. So this is what allowed us to call build once we had the Scotch builder with all the types. Now in more modern Scala, we turn the def enable build into something called an implicit class, and instead of it being a structural type, it now is a natural class with a method, which looks a bit more sane. It functions in pretty much the same way. In fact, this kind of gets translated into some class with an implicit def. But there'll be links at the bottom. You can read some more about that. This is just a bit of a style change and a language change. I think the article was pre-Scala 2.10, and I think post-Scala 2.10, this became effectively the way of doing it. But I've changed it so that the following examples will use this and not the old way. All right. So now my riffing, okay? And I've already blown more than half of my time, which is not a good sign. Okay, so the first riff is let's not have separate phantom types for true and false. Let's kind of lift the H and M and the stuff to be their own phantom types in a way, right? So let's have a trait for has brand, a trait for has method, and a trait for has double status, etc. And we will say that something is met the requirements if it has the three things that are necessary. So it has the brand, it has the mode, it has the double status. If it has more than that, so if it has, for example, the HG, which I've added, then that's fine. If it doesn't, then it's not fine. And this thing, this with, is called a compound type. I think the first version of this I wrote, I call it an intersection type, which apparently is not quite the same thing. And I invite you to go and read some stuff about .t, and you'll kind of see why. But so that I'm guarding myself for the people who are really experts. This is a compound type, right? It's not I understand it's not an intersection type. So we have this compound type, this thing with, that's the requirement. And so that's the first riff. The second thing is, instead of making it a type parameter, we introduce this thing called a type member, which, for all intents and purposes, is sort of the same thing, but it's not quite the same thing, and there's some ways that you have to kind of work around that it's not the same thing. And that's all I'll really say about it. Again, there are people who said this much better than I, and I'll put links at the bottom, right, about it. But because we decided to just use type parameters inside of type members, we have to use, or it's suggested that we automatically do this thing, which I don't know if anyone's ever heard of it, but it's something called the aux pattern, which is effectively two things. The first thing is to create a nice alias that allows you to not have to write every time the stuff in the curly brackets, right? Which is called refinement, but again, by the by, you can kind of check out a bit later if you want. But if you have an alias, it just makes it a bit easier for you to kind of write it. And actually, then it makes it a bit easier for you to work with it as you call each of the methods. And the second thing is you make this generic apply that, again, allows you to not have to write this boilerplate every time to assign what the type of properties is. This is just a feature of working with type parameters. And I've just plastered all of these three different things on this slide for no reason other than I'm riffing. And I just want to give you some stuff to go and read as homework in your leisure time, right? And then the final thing, we're using the same method of adding an implicit conversion to add build on our Scotch builder. But this time, instead of looking for true, 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 what we're looking for is, by the end, we want to have some compound type that is a subtype of required. So if it has HB with HD only, that's not a subtype of required, because required is HB with HD with the other thing. If it has more, it is a subtype. That's fine, it's more specific. If it has less, it's not. If it has the same, it's a subtype. Again, better seen than a REPL. Happy path, nice and easy, the thinking path. So we can see the slight difference in the error message. So instead of true or false or true, now we see we have an HB with an HD with an HG. And it says it still can't find the method. Again, let's try to break it down in steps. So we started off with this as the builder. And there's this funny underscore thing, which I really won't explain too deeply. Again, it's in the links. This is, you can see that this massive warning underneath the expression, which is a compiler saying this is actually some really bunker shit you're trying to do. So maybe rethink what you're trying to do here. But I'm riffing. Let's just do it, right? Let's just get into it. But essentially, you're creating some existential type, which you can't really speak the name, right? It's kind of unspeakable. It doesn't have does that make sense? It sounds really philosophical. I love it, like a type of which you cannot speak. But I have not found another way to make it work. But essentially, that's what you start off with. And then at each stage, you call the previous properties, and you mix in the new property that you've encountered. And it flows down right to the end, where if you've called everything correctly, you get it's a subtype of required, and you can then call the dot build. So please look at the further reading. In particular, there's an article on the type level blog called Type Members and Type Parameters. Written is like a 9-part epic series. It's really, really good. I read it all the time. Like, go back and forth. I'm like, I still don't quite get it, but I get up to 5, and then I read it again. I get up to 6 now. Yeah. I think I'm maybe up to 7. Eventually, my goal is to understand all 9, right? Read it by a chap called Stephen Compal, or I don't know how to pronounce the last name, but that's his name. Okay. I have to confess. So that thing with the underscore, I just discovered that by accident, really. Because the first time I did it, I thought, let's make it nothing. That seems right. Yeah? It makes sense, right? Instead of saying some type of which I cannot speak its name, it's more intuitive to say, it has nothing. The type is nothing. There's no type. Yeah, that doesn't really work. Sad, unhappy path again. Sad, crying path. Bang, it blows up. And it blows up because it turns out, nothing is the subtype of everything. It's the bottom type in Scala. Which I did know before. But what surprised me is, once you mix in nothing with anything, it becomes nothing. So I suppose intuitively, what you're doing when you're building a compound type, you're kind of making a product. So it's like 0 times 0. 0 times anything is 0. So nothing times anything happens to be nothing. That was an interesting find. So that's why I ended up having to use the underscore, and I don't know if there's another way. Maybe somebody who's a bit more brilliant can tell me. But this is a nice segue to what I hope is the next approach, which is, the next approach which I'll show. There's these nice little tools which you can use on a REPL to kind of verify type relationships. Again, won't go into the details, read that stuff there. It's a really nice article called Generalized Type Constraints Without a PhD. Really well written. But the idea is that you can use these two kind of tools, I suppose, the implicitly method and this fancy looking library, this fancy looking class that looks like an operator, to test the relationship, the type relationship of different classes. So we've tested here that nothing is a subtype of string, that int is a subtype of string, and that int with nothing is a subtype of string. And when it blows up with an error, it means it's not a subtype of, basically. So the cool thing about that is, notice the error message I think is a bit more helpful. So I started this by saying that we should see the compiler as like a feedback tool, right? But if it's a feedback tool, we want the messages to actually guide us in the right direction. It turns out the methods that we've used, the original Typesafe style and this, my riff on the compound style, they give you an indirect message, really. I mean, it tells you that build is not there on this Scotch builder. And then you look at the class and you're like, but there's no build. Of course there's no bloody build. It's what are you telling me here? It says nothing about it's trying to enforce some constraints. Whereas actually this error message here seems to be talking a bit more about constraints. So maybe that gives us a clue on the final riffing approach that we can kind of take. So, yeah, so that's basically what this is saying. Maybe we can get the compiler feedback to be something along these lines, as opposed to just a method is missing. I think it's easier to work with if you're in an IDE or you're going through some docs. the implicit conversion, one of the reasons why it's sort of gone out of fashion is because it can be really difficult to work with. You just get this error, maybe you get something that just turns red and you're like, I have no idea why this is red. You know, there's no help in the IDE for me to tell me that the next method is this, and the IDE can't resolve the implicit, and then you're banging your head on the table. So this approach makes it a bit easier. So instead of using implicit conversions, we use something called implicit parameters. And I'll try to whistle through the last bit, sadly, because I see I'm at 25 minutes already, so I don't want to take up too much more time. But one of the cool things, so I've tried to like elide the bits that are the same. So this is exactly the same as a Typesafe style. You know, the same class Scotch builder, the same with brand. I've gone back to using the phantom types true and false and the type parameters. But instead, I've moved the build method from some implicit conversion back into the Scotch builder. And instead, what I've done is to put these implicit parameters on build. Now what these do, these provide some kind of constraint that the compiler will try to check for you, essentially. Right? So each of these are sort of like you saying, this is some theorem that must hold. So the property HB must hold true, the property HM must hold true, and the property HG must hold true. And what the compiler will do is, they're actually, this is it'll look for a value for rec1 that has type of that represents a natural type, and the compiler will try to find this implicitly. It'll look for an implicit instance that's somehow in scope, and if it finds it, then it says to you, life is good, I've proven what you want to prove. If it doesn't, then it will give you some error message saying, I couldn't prove what you wanted me to prove. So let's see what that looks like. Oh, I haven't got there yet. All right, yeah, so I just wanted to show you the difference between the old one where the builder was outside and the new one where the builder is on the inside. Back at the REPL, this is what we have. Happy path, nice. Thinking path can't prove that this theorem holds. Yeah, which it feels to me, I mean, you maybe completely disagree. It feels to me that this is a better error message. It gives me more feedback. I can actually work with this a bit better than the one where build was not on this thing where build, I can't see where build will be on anyway. And we can see why that happens because in this case, we haven't called with mode. So we haven't done the bit that will allow it to resolve rec2, that HM is equal to true. Okay, so it will try to solve each of these, find an instance for each of these implicit values, parameters in turn, and if it can't find one, then the whole thing bums out. Okay. Yeah, coming towards the end. Now, it still doesn't quite give us a feedback that expresses something to do with the domain, though. This feels still a bit generic. And now it turns out that where that error message comes from is actually through an annotation that you can make yourself, which the compiler uses anytime it cannot find an implicit that you tell it to try to find. It will use this annotation that you've given. So we can see that the prove thing actually comes from that definition that's on the class type equals, cannot prove that these two things equal. So maybe we can use that same implicit annotation to make the error message a bit better. Of course we can, if not I wouldn't have put it on the slide. So how we do that, we wrap the requirements that we need into basically another type, right? So we say, well, let's have a proof of valid drink, which has these 3 type parameters. And we will provide a single implicit definition, which the compiler, when you ask it, will find this. But that implicit definition has other implicits, which are the requirements. And it turns out the compiler will just happily continue going on a journey as long as it takes to satisfy the original one. So if you ask it for one implicit, which we ask for the build here, and to find that implicit, it needs to resolve other implicits, it'll just keep going until it just can't go anymore, and then it will tell you I had to stop. So we've basically, that's what we've set up here. And setting it up with its own type allows us to provide our own annotation, which is a bit more domain specific. Now, one thing I'll just call your attention to is the slightly ugly, I suppose, null that's there, which, again, Scala top people are probably, yeah, what's this null thing? This is awful. Now, it turns out this is sort of valid because you'll never use this type. You'll never use this instance. This is never something that you'll grab onto, because if you did, you'll get a null pointer exception. This is only useful for the compiler to resolve some stuff at compile time. So having a definition just means that it can do its work, but then there's nowhere in your code, hopefully, that you're going to pull a value of this thing. You may also see people using the 3 question marks, but it has the same effect because the 3 question marks, it works because it's a nothing type, and nothing is a subtype of everything. Null is also a bottom type, so it can be a value of a proof of valid drink. And again, at the REPL, happy path, thinking path, and our error message is a bit more helpful. Okay? And the very last riff was basically the same thing, but splitting each one in its own wrapped type equals, so that you could say which method was missing. So instead of one thing saying all these, one of these methods was missing, we can say which one in particular. But it's exactly the same approach. Yeah, does that make sense? And at the REPL, this is what happens. So you call with mode, it doesn't work, and so with mode is not there. Okay, and that's pretty much it. All of that talk was basically to get you to read some stuff. Right? And I'll provide these, the slides to Alice and the Linux Recruit guys, or to maybe I don't know who to, somebody. Somebody will have the slides. They'll be somewhere at some point. Okay, there you go. And then really, have a go at reading some stuff. It's really a fascinating exercise just to learn some new stuff about the Scala type system. And that's it.